Hello from homeschool. I hope y'all are doing well. Today we're going to look at motion. And as you will remember from our force and motion unit, motion is movement from one point to another. Okay? So the difference between motion and movement is that motion is from one point to another, whereas movement can just occur in the same location. So motion is a vector quality. Speed is one of the first things we talked about. Speed is how fast something goes. Okay, that's the easy definition, and its formula is distance over time, which we usually see as S equals D over T. And then our triangle looks like this with the D on top. The unit for speed is going to be meters per second, with distance measured in meters and time measured in seconds, but it could be any unit of distance or time. Velocity is going to be speed in a given direction. Okay, so once again, velocity is a vector quantity, whereas speed is a scalar quantity. So velocity is still going to be d over t. So v equals d over t. Will be the same calculation, same triangle. But when you calculate your meters per second, you need to make sure that you have a direction in your answer. Next, we have acceleration. Okay, so acceleration occurs when there is a change in speed or direction. Okay, it's speed or direction. So you can speed up, you can slow down, or you could be going the same speed but just change your direction. So that's very important. And another key thing to keep in mind is that acceleration is caused by unbalanced forces. Let's look at some of the motion graphs that we need to understand. First one is going to be our speed graph. So we have our distance on the y-axis and time on the x-axis. The first example would be an upward turned curve, and that's going to be positive acceleration. So the example would be like speeding up. A straight line is going to be constant speed. It's like cruise control. Remember when we talked about cruise control or coasting on your bike? Okay. A downward curve is going to be slowing down or negative acceleration. And if you see a flat line, okay, flat line means there's no change in distance. So that is when we would have our object at rest or stopped. And always remember that the origin is wherever our journey started there, okay? So that's at zero distance. So that is going to be our speed graph. The next motion graph we need to look at is going to have speed or velocity on the y-axis with time still on the x-axis. So when you have a straight line, that is going to show you positive acceleration or speeding up. When you have a flat line, that is going to be constant speed. Okay, so you're going to notice a few differences. When you have a line going back to the x-axis, that is going to be negative acceleration. Okay, The only time we have at rest, we can show at rest on this graph is if the line is on the x-axis, and that is going to be stopped or at rest. So notice the differences between acceleration, constant speed, and at rest between the speed graph and the acceleration graph.